Statisticians. I decided to have part 2 of these little videos about using the standard normal tables to find probabilities and the like. This time, we are going to be given an area under the curve, also known as a percentile, and we're going to try to find the correct, find the percentile for a given area under the curve. In other words, we want to find the z-score if we're given a particular percentile. So we're just going to do, again, 3 super fast examples. First, the 50th percentile. That would mean we want to know the z-score so that if I was to shade in 50% of the normal curve, that it would have 50% beneath it. Now that percentile is pretty obvious to find, right? I want to know the z-score so that 50% is beneath it. Well, that would be 0, right? That would be literally in the middle. That would be the mean, because if you shade in everything to the left of 0, right, we can see very clearly that that's half the normal curve. So the z-score for the 50th percentile would simply be 0, right? Now, if you didn't know that, you could just look at the standard normal table, and we can see pretty clearly by looking now, instead of on the outside for z-scores, looking for 50% in the middle of the table, we can see right here, smack dab, let me see that right there, that says 0.5000. And now I can work my way out, and I can see 0.00 would be the z-score for the 50th percentile. So that's kind of how this works. We're going to look for the area or that percentile in the middle of the table and go to the outside to find the z-score. All right, so now, how about the 90th percentile? Well, let me sketch something. Here's a normal curve, more or less, right? And I'm going to start labeling some standard deviations. Now, I want to estimate real fast where I think the 90th percentile might be. From a previous class, we said that the one standard deviation above the mean would get us to the 84th percentile. And we said 2 standard deviations above the mean should get us the 97.5th percentile approximately. So the 90th is going to be somewhere in between. I don't really know exactly, but I do know that were I to shade everything this way, that this area, I'm just going to say, let's just say this area is 0.9 or 90%. So if I want to find the z-score for that, I'll go to my table. Now I got to look for the thing that's closest to 90% in the middle of the table. I'm going to use pink here. I got a bunch of colors going on. That's all right. I'm looking for 90%. Here I see 70s, 80s. Ooh, check this guy out. Right there. 0.8997. I mean, that's not exactly 90%, but gosh darn, that's only 0.03% away from it. So I'm going to look and see, well, what was that? If I go up, I see 0.08. If I go to the left, I see 1.2. So that would be a z-score of 1.28. And so that means 1.28 is the 90th percentile for the distribution of z-scores. Of course, I didn't write this at the top, but of course, we're assuming that z is approximately normal with a mean of 0 and a standard deviation of 1, right? So for all of our z-scores, this guy right here would be the 90th percentile. Okay, so let's find the 50th. Actually, I didn't ask for the 50th percentile. Notice that this just asked for the middle 50%. Middle 50%. All right, well, that would mean that if I was to shade a normal curve, so here's a normal curve, right? If I was to shade it, I'm going to go out symmetrically about the mean, and I'm going to try to get to 50%. Now, we learned from a previous class that if I was to go between -1 and +1 standard deviations from the mean, that would be 68%, right? You guys remember? So that would be 68% from between there and there. So 50 is less than that. So I'm guessing that these boundaries are going to be slightly less than 1 standard deviation on either side of the mean. And this is what I want. I want to find, I should have used a different color. I used green again. Makes me a little sad. But this is supposed to be 50%. Now, how the heck do I find that? Well, I can't look that up on the table. But what can I look up? If this middle part's 50%, I could use symmetry to say, well, these 2 outside parts have to add up to 50% themselves. So that would mean each side would have to be, well, 25% and 25%. All right, well, what's the z-score going to be for the 25th percentile. Well, let me bust out my table. And since 25% is less than 50%, I'm going to go to the negative side. And let's take a look here. I'm looking for 25%. I'm looking for 25%. Hey, 0.2514. Hey, we used this guy earlier. Oh yeah, 0.2514, that's pretty gosh darn close to 25%. So I'm going to estimate that 25th percentile is about negative 0.67, right? If I go out. So that would mean that this is around negative 0.67, right? Well, then by symmetry, what do you think this boundary would be over here? Well, let's think. If that's 25%, that's 25% above. Wouldn't that just be a positive 0.67? Oh, it absolutely would. Well, let's check. Let's just make sure. What should we find here? Well, let's look at 0.67, 0.67, and it says 0.7486. Well, shoot, is that the right thing? Well, heck yeah, because remember that if this boundary would actually be the 75th percentile, right? 75% would be less than whatever this boundary is here, 25 plus 50. Now, again, 0.7486 isn't exactly 75%, but it's pretty gosh darn close to it. It's off by 0.14%, and so for our purposes, it's close enough. So I'll say that the boundaries for the middle 50% are negative 0.67 to positive 0.67, right? 1.28, remember, was the 90th percentile, and the 50th percentile was just 0. So again, I'm glad that we can do this. Hope you're having a beautiful day and enjoy. Adios.